Hey, sixth graders. Today we're going to take a look at a concept called factoring. Now, when we're factoring, we are still generating equivalent fractions. So it's really important for you to understand that we are not changing the value of the expression at all. We're just making it look a little different. And what we're about to find out is that factoring is essentially undistributing. So it's essentially the inverse of the distributive property. And this is going to have a lot of benefits and is helpful in applications is what I'm looking for. A lot of applications when you get into higher level algebra. Being able to factor will help you to solve problems a lot easier. So we're going to try and master this skill. Now. So when factoring expressions, the key word here is factor. Now, if you remember, factors are numbers you multiply together, and that's kind of our clue as to what we're trying to do. So when we're factoring, we are trying to represent the expression as the product of two factors, of two things that you're going to multiply together. So in a sense, we're going to be undistributing the expression. So by the time we're done with it, we are putting ourselves in a position to be able to redistribute. So you're going to kind of make it look like an expression that's ready for the distributive property. So here are the steps to be able to factor expressions. The first thing we need to do is find the greatest common factor between the constant and the coefficient that are being added or subtracted. So here we've got 15b plus 18. So the factors of 15, so I'm just going to look at the coefficient there, and the b is just going to come along for the ride. So the factors of 15, we've got 1 and 15, 3 and 5. And the factors of 18, we've got 1 and 18, 2 and 9, 3 and 6. And so our greatest common factor here is 3. Both of them are indeed divisible by 3. Oops. So our greatest common factor is 3. So what we're going to do next is we are going to rewrite each term. So each one of these, remember, terms are separated by plus and minus signs, as the product of the greatest common factor, which is 3, which is really important, which is 3 here, and its remaining factor. So whatever other number you need to multiply by to give you your original term. So again, my term here is 15b. So I want to write that as the product of 3 and something else, so that when I multiply them together, I still have 15b. Well, 3 times 5b will get me back to my 15b. Let's take a look at the 18. Well, that's going to be 3 times 6, because that gets you back to your 18. And again, we're right back to our original expression. So I have not changed the value of my expression at all. I'm just making it look a little bit different. I'm breaking up each piece into 3 times something. And the reason why I'm doing that is because our last step here is that we are going to pull out that greatest common factor. We are going to undistribute that 3. And you're going to see me doing some crazy hand motions where I literally, it looks like I'm grabbing a number and I'm pulling it to the outside of the parentheses. So what we're going to do is we're going to take that 3 and we are going to pull it out of that expression. And this is going to be 3 times the 5b, and the 6 is remaining. Okay, now I know it looks a little funkadelic with all these different colors and with the parentheses that are super tiny. So what we just did was we undistributed. Okay, we pulled a number out that was in common between both of them. So I want to prove to you that this is still equivalent to our original. So what we've created now is 3 times 5b plus 6. Now let's redistribute to see if we get back to where we had started. So this is our factored product here. But if I use my distributive property, I am right back to 15b plus 18. And I know I've done it correctly if I redistribute and I get back to where I started. But this right here, if I ask you to factor, this will be your final product, or this, really. That looks a little bit neater. Let's do some examples.